Okay, so on this table, it turns out when we go to graph polynomials, that the degree of the polynomial, if we have a certain degree and we have a certain a, that end behavior is the same for all of them. So today we're going to do even when a is positive. So if our degree is even and a is positive, our end behavior is going to be left, up, right, up. Always. So you want to fill that in your table. So today, all we're going to be doing is the a is positive. Tomorrow, we will mix up the a is positive and the a is negative. So then on odd, degree of polynomial is odd. If the a is positive, it is left, down, right, up. Always when that degree is odd. Okay, so we're going to use that to make some graphs today of polynomials. Is there anybody that's still looking at this? Okay, moving on to the next example. So the other side of your paper. Okay, so we are going to graph this equation, y equals x times x minus 5 times x plus 3. So at this point, we don't know how to graph this, but we're going to use this end behavior, etc., to graph it. How do we find the roots of this equation? When we say roots, what part of the graph is it? The zeros, which are where they cross the x-axis, and those y values, that y value would always be 0. So we set 0 equal to x times x minus 5 times x plus 3. Does that make sense? So what would we do next then to solve it? Zero product property. We're going to set x equal to 0, x minus 5 equal to 0, and x plus 3 equal to 0. So this one's solved for us. This one gives us x equals 5. And this would be x equals negative 3. So my roots are 0, 5, and negative 3. So I'm going to graph those points. 0, 5, and negative 3. So my degree. If it were in standard form, it's much easier to tell what the degree is because it is the highest, a term with the highest exponent. It's not in standard form. Anybody have any idea how we might find the degree on this one? So think about if we multiplied it out, what would be the exponent on the x? 3. Did somebody just say 3? Yes. So notice you have x times x times x, which would be x to the third. So our degree is 3. Questions on that? Since you have 3 x's there, 1x here, 1x here, 1x here, if you multiply them all together, you would get x to the third. So that's where the degree of 3 comes from. So our end behavior, now we look at our table. Is 3 odd or is it even? It's odd. So we look on the table and we say, let's see, let me go back to here. Is this a positive or is it negative? What is our a on this? 1. And what does a mean? Where do we get a? A is going to be your leading coefficient. So our leading coefficient on this is assumed to be a 1. Does that make sense? So your a is equal to 1. So it's positive. So we're going to go to our table. Our degree is odd, and A is positive. So it's left down, right up. So our end behavior is left, down, right, up. Questions on that? Okay, so our y-intercept is, what does the y-intercept mean? Where the graph crosses the y-axis. Any point that crosses the y-axis has an x value of 0. So we're going to take our equation, and in place of our x's, we're going to put a 0. I would say of all of them, this is the one that requires the most thinking. So this would give us 0 times -5 times 3. What is that going to give us when we multiply it out? 0. So this gives us a 0. Our y-intercept will be 0, 0. So we don't need to label that. We already have a point at 0, 0. So now we're going to start out with our end behavior. On the left, we go down. So on the far left point over here, we're going to start down. So we're going to have an arrow that goes down. And then between each of the roots, we're going to have one curve. So it's going to go curve up and down once. So we don't care how high we go except for the y-intercept, okay? Or x-intercepts. So now we stop here, and then we go from this point to the next 0 or root, and then we would do one curve to the next point, and then you can tell that it's going to keep going. It's going to go up. And notice we end right up. And so that worked. Would you like maybe to repeat what I just did? Okay. So on the left, I started out with my left down. So I started down here, went up through this point, and I made one curve up here between this point and the next point. And then I continue going down this time, and I make one curve between this point and this point. And then I go up, and I'm ending right up. That checks, so I'm good. Okay, can I go on to the next example? Okay, so now our equation is, let me talk about what this says here. It says find the roots, degree, end behavior, and y-intercept, then graph. You will be graded on x-intercepts, y-intercepts, and end behavior. So back here on this one, y-intercepts, x-intercepts, and end behavior only. So we don't care on this part how high it goes up, or this part how low it goes down. Those are called relative maximum and minimum. You will see that in pre-calculus. And talk about that in pre-calculus. Okay, so on here, how do I find my roots? That's for one of them, but so we're going to first set our y equal to 0. And then what do I do with 2 there to solve this? Yes, that would be the fastest way, is just dividing both sides by 2. Because it's equal to 0, we can divide that by 2, and it just goes away. So now to solve that, we take x minus 1, set it equal to 0, x plus 3, set it equal to 0, x plus 1 equals 0, and x minus 4 equals 0. Okay, so what's my degree on this one? What do you guys think? She said 4. How many x's do you have listed here? 4. So just be careful. If it has an x squared, that would really represent 2 x's, right? So yes, there are 4. And then look at your roots. There are 4 roots, and the degree is 4. Those should match. So my end behavior, my degree is 4. Is 4 even or odd? It's even. So what does it say for my A on this one is? Positive. It's a 2, which is positive. So my A is positive, my degree is even. What's my end behavior then? On your table that says left, up, right, up. Questions on that? So y-intercept, remember the y-intercept where it crosses the y-axis has an x value of 0. So we're going to take our equation and put a 0 in place of the x's. Don't forget to put the 2 there. Common mistake to not put that 2 there. So this would be 2 times -1 times 3 times 1 times -4. So feel free to use a calculator if you want to do that. Do that in your head. What does this give us? So we get 24, right? So as a point, that y-intercept would be 0, 24. So let's label the roots 1, -3, -1, and 4. So if I, as I did on my x-axis, went by increments of 1, 24 would not fit on my graph. It would be way off the graph. I can make my increments different on my y-axis than my x-axis. What should I make my y increments to make a 24 fit here? Could do 6 or 4. I'm going to go by 4. So I did not label all of them. All I need is a 24. So I'm going to put a point here. And now I can start drawing my graph. So on the left, it is up. So I'm going to start on the far left from this point. I'm going to start up. And then I'm going to go down one curve from this point to this point. And then I'm going to go one curve from this point to this point. But I have to go through that y-intercept. This time it's way up here, so I have to go through that. Does that make sense? And then I'm going to go one curve from here to here. And then my end behavior is right up. So I'm going to end up. What letter does that kind of look like? Kind of like a W. Yeah. Okay, we're going to do one more. You look very nice, David. You look very nice, dressed up. Can I move on to the last example? Okay, to find my roots, set y equal to 0. And I get -1 and 4. What is my degree on this one? It is a 2. I have an x times an x squared or degree of 2? Questions on that? How we got the degree of 2? Is that even or is that odd? Even. So what's my A on this one? It's a positive 1. It's assumed to be a positive 1 right here. So my A is 1. So it's A is positive. Degree is even. So what's the end behavior? Look at the even. So even A is positive. Is left up, right up. Hopefully your table's labeled correctly. Questions on that? Okay, so my y-intercept, remember, is my x value is what? For the y-intercept, what's your x value? 0. So it's 0 plus 1 times 0 minus 4. And so 0, -4 would be my y-intercept. So this time I didn't have to go off the graph, so I can still use increments of 1. So my end behavior is left up. So on the far left point, I start up. I come down through this y-intercept. I'm going to keep going down because I know from previous experience that when I go through that y-intercept or that lowest point is going to be halfway between those two, and that's not halfway between, so I just kept going down. But again, we're not worrying so much about that. And then I end going one curve here, and then I end up. Questions on that? Okay, go ahead and do the U-try. So that was the y-intercept at 0, -4. Right. So this would be a y-intercept of 0, -4. So that's the hardest part of it, I think. Yeah. Yeah.
So what numbers do you use for this part?
So you find the degree. So you're looking at, like here, there's 1, 2, 3 x's. So that's the yes, this is the degree. How many x's here? 2. And you have to be careful because if there's an x squared, you have to count that. X squared is 2 x's. So it's 2, so the degree is 2.
But to know if it's left down, right up.
So its degree is 2. What's your A? Is it positive or is it?
Positive.
Yeah, so A is positive, degree 2. So you go to the back.
Oh.
Yeah.
Okay. I thought that A was what you used for this.
Oh, okay.
So it's the degree.
You both.
Or,
Both A and the degree, yeah. And the A is a little new, so that's understandable. They're still getting there on that.
You need something right.